Right. Page 44, using an equation map. Take a second, underline what you think is important, and then come back to us. Okay, so I haven't underlined yet, but we're going to do this together, right? So what we want to do is, actually, none of the steps are there. Okay, so here we have the steps. Simplify by removing zeros. Add balanced sets to each side and remove zeros. And then that's the last part, right? Okay, so we're going to look through this. We're going to just go through this example. Here it says, simplify each side by removing zeros. Now, when you do your test, you want to look at what you highlight, right? So here I have, these are my negatives and my positives. I can get rid of some of these, right? So if I have 4 positives, I can get rid of 4 negatives because they make 0 pairs, right? On this side, I can get rid of an x and a negative x because they make 0, right? And then they just organized it. So this is 1, 2, 3x. This is 1, 2, 3x, right? This one, there's only 1 negative x left, 1 negative x left, right? So there's where it simplifies. Then what they do is they add balanced sets to each side, right, to remove it. Now, I want you guys to see this. This is where it gets confusing. Okay, here, to get rid of my 2 negatives, I need to add 2 positives. I want you to add this in your notebook. If I add it there, I need to add it here too, keeping it balanced. Now I've got my 0 pairs. Okay, pause and rewind it if you get confused. Here I have, so I'm bringing all my unit tiles to one side. Here I have a negative x. To get rid of that, to keep it balanced, you got to add a positive x. If I do it to one side, I have to do it to the other, right? So there it is. Here is now my 0 pair, no matter what number it is. A million and negative million make 0. And then they cleaned it up, okay? So now we have 4 x's, right? So we've got these 4 x's are now these 4 x's, right? Then we've got these, 12 is going to be these 12, okay? The last part, because there's more than one x, right? This won't happen all the time, but if there's 12 that represent 4, and we only want to know what 1 is, we have to divide this into 4 sets. And it's actually beautiful the way they organize it, because that is 1, that is 1. That means that each x equals 3, right? And we can see this. Or the way they do it is they take the 12, divide it by the 4, and you get 3 for each one. Okay? Visualization is awesome. It takes longer, but it's good. So I'm not going to do any practice problems for this one. But yeah,